Now we will show which files are used behind the scenes by the contrep performance requirements validator that in an example we have executed right after the simulation, but we can also execute individually or as a single step once at least one simulation has been done. As I said, a simulation needs to be performed because right after the simulation, an XML file with the output metrics required for performing the validation is generated. We can open this file. This is XML file, and as we can see, the file has a system metric entry for each output metric that needs to be reported for the performance requirements validation. This file has to follow the multi-giver specification. That means that a strict naming has to be done for the metric. Certain characters are not allowed. So the metric names employed by a specific performance analysis tool, in this case VP, have to be translated to a specific format that has been defined, and that enables to trace and identify the type of metric, that the metric is estimated by a performance analysis tool, and that the metric is related to a specific element of the model, or in some cases we have also global metrics that are applicable regardless of the model. In this output file, we have the value reported by the metric. That values are associated to a unit that has been specified in a different file, so-called design space file, and that was provided as an input to the performance model, and that is used for this performance model to know which are the units associated to those values. Apart from that, we can comment that as well as global metrics and metrics associated to a specific instance of our platform, we can also report, as we do it in this example, application related metrics, in this case response times associated to different elements of our model. As well as these values of the output metrics, we have another file read by our performance model validator, which is the requirements file. This file is statically generated, so it's associated to the model, which, as well as the system model, it also captures the specific metrics that we want to use in our exploration, the criticality associated to those metrics, and then associated to then also the specific expression, conditional expression, which states the performance requirement. This is different from this file is statically generated in the sense that it's present already in the model, and this is different from the output XML file, which is generated by the performance analysis tool, in this case VP, and that it's the results of applying that performance analysis tool to the model. So our performance requirements analyzer basically reads these two files and computes this expression upon the values that have been reported by the performance analysis tool via the output.xml file, and then provides the results to the output console. Once we have this file, it's possible to execute the performance requirement validator as many times as we want, so cannot be executed not only right after the simulation, but can be also re-execute. So here we see that performance validation results. Here we see that the performance requirements analyzer is triggered, and then the repose for each single requirement, and then the end of this performance requirements validator. In this case, as we saw in the simulation run example, we see that every single requirement is fulfilled.